So one of the real important topics in release control is test-driven development. And it goes a little bit beyond release control, but it is very, very important in allowing all these new ideas, these solid ideas to be used. The big idea is you write tests first. You write your tests before you write your code. Now, that may seem a little bit unintuitive. Now, how do I write my test if I don't have the code yet? How can I write a test until I see what the code does? Well, how can you write the code if you don't know what it's supposed to do? When you apply test-driven development, when you write your test cases first, your tests become essentially a requirement specification for your code. So if I've got a class I need to write and some methods I need to write, I think I know what the methods need to do, so I write some test cases. And the test cases call the methods and they specify what inputs I'm supposed to, I expect and what outputs I expect. And I get those tests done. Well, once I write the tests, what happens if I run them? Well, of course, they're all going to fail because there's no code yet. But now I can go write my code and I've got a good idea of what it needs to do because I've already thought about what it needs to bring in and what it needs to send out. So I work on my code and I can repeat and I can iteratively write some code, run some tests, write some more code, run my tests. And how do I know when my code is done? Well, all the tests pass. In agile development, we know there's an emphasis on just enough documentation. The test suite, the test cases essentially become your requirements. If the test cases are well crafted, you don't need a real heavy requirement specification because you can look at the tests and see what the code is supposed to do. And the real important thing for release control is that when you apply test-driven development, your testing is never behind development. Your testers are never, behind the 8-ball or behind the curve. They're never scrambling to keep up with changes because every time there's a change or every time there's new code, we've got new tests. And that allows you to smoke test every build. Smoke tests, my favorite term. I love that term. Right? Where do we get the term smoke test? It derives from hardware testing. Now, in the past, I used to do embedded development for motor controls and some heavy equipment where literally if something went wrong, we could certainly cause equipment to catch fire or explode or smoke. Things get pretty dramatic, right? So a smoke test in software is generally a limited test. It's a quick test, but it's run on every build. And the idea of the smoke test is to confirm that the software essentially works. Once you get a release done, obviously, you're going to call in the QA team, you're going to call in the testers, and they're going to do a lot of work. Well, testing's expensive. So a quick automated test that verifies that the software is pretty much intact and ready to go can save you hours and hours and hours of effort. Now, it only works well if they're automated, so you can use them very, very often. Now, how much do you put in your smoke test versus a QA test? That's up to you. And it really depends on the nature of the software you're writing, how many resources you have for automated test versus any manual testing. But it is true that in general, the more tests you can automate, then the more and better testing you can do, right? So you don't rely on human beings who get tired, who may make mistakes and whatnot. Let's switch and think about jobs, right? Jobs is pretty much what it's all about. It's why we get some education, because we want to get a better one. So what can you do with knowledge of release control, version control, and test-driven development? Well, I see people with these knowledge working with titles like build engineers or release engineers. Sometimes you'll see them as tools engineers or toolsmiths, right? These are the people who build infrastructure for software teams. And I've also seen this title of software developer and test. And I kind of like it because it suggests that people who do test work need the same skills and knowledge and presumably the same kind of pay that a traditional software developer would get. Now, you might look at that and go, oh, well, I don't really want to be a build engineer. My goal is to be a developer. I want to write software for a living. Well, that's great. Well, a developer who's got a good understanding of release control and version control and test-driven development, well, they have an edge because they know more about how software is actually delivered and created than just the engineer who sits at a desk and writes code all day. So please keep that in mind. As you move up and you get some more experience, you'll see titles like the release engineering team lead, or maybe a DevOps engineer, particularly in companies that are adopting containerization, that are moving to DevOps, this merging between development and operations. You'll see titles like system administrators, particularly where there's a lot of infrastructure and machinery to keep track of. You might see titles like build master, especially for very large organizations. If you've got developers in 3 or 4 or 5 sites around the world, if they all need to collaborate with some cloud-based infrastructure, then it's very, very common to see people who specialize in keeping all that infrastructure running. You might see some titles like support programmer, or, and this is, I think, more for organizations that are building software as a service or online services. You'll see titles like site reliability engineer, the people who keep the lights on for these online services. Top management's a little bit more interesting. I don't see release control being the only skill here needed for a top management role, but you'll see people with release skills growing into titles like infrastructure manager or release engineering manager, systems manager. Another thing that's fairly common is that senior release engineers will become consultants. Now, depending on your experience, that might be a technical consultant. You work with an organization to get their infrastructure built out and get their people trained, or it might be a corporate consultant where you're working with very senior management, guiding the direction of an entire company and how it does its software development. Okay. That being said, I don't want to leave an impression that you can go take a class in release control and then you can become a chief technology officer or a chief information officer. Those roles take a lot more and a lot broader knowledge, not only of technology, but also of business itself. That being said, a CIO or a CTO who really understands how software is built, who really understands how software infrastructure works, they have an edge. That may not be all that you need to know, but it certainly is necessary for you to know it. Okay, so we said earlier on that we want to pull this all together. And so I want to talk about a CI/CD pipeline. Because today, this is really what version control and test-driven development is all about. So what happens in a CI/CD pipeline? Well, we start up here on the left with version control, right? Version control is the basics, right? Version control is that piece of software, that system that keeps track of every source code file, every change you make, keeps track of all the identification that we've already talked about, and keeps all the software together so you can build it when you need it. So the CI/CD pipeline starts when a developer checks in some code. Boom, it's in version control. So what happens? Well, the pipeline, and this might be a tool like Jenkins or Hudson or Circle CI, right? There are many of them out there. We'll check the code out of version control and do an automated build. Now, if the build completes, this is a compilation in Lync, great. If not, it pops back an alert, maybe an email to the build master or a message to the developer. This change didn't work. If that happens, okay, back it out of version control and try it again, right? You broke the build, we can't go forward. If the build is successful, then the build signals a smoke test. And again, this is where test-driven development comes to the fore, because that smoke test needs to be automated. And if it's automated, it's ready to go. So it can be run from that Jenkins pipeline, from Circle CI. You can run the test and report back. Did it pass? Did everything pass or not? So if it passed, great. You can move it on to QA. And here again, test-driven development comes to help you. Because if most of that QA testing can be done automatically, you can automate that too in your pipeline. So let's say you've done that and it passes QA. Well, now it's time for automated deployment, and the pipeline takes care of that as well. Now, that might be, depending on your product, that might be build an installer or build a tarball. If for an online service, it might be, okay, deploy this into production. And finally, you get to production. Now, what does that allow you to do? Remember, this starts from version control, which means you can run this pipeline, and you should, on every change that gets checked in. Now, you might say, okay, we're only going to run the pipeline for changes to the master branch, right? You may have some restrictions like that, but you can run the pipeline on every change. So you don't wait an hour, you don't wait a day or a week to find out if a change is good or not, because you've got testing automated. You've got the pipeline backing you up. So a developer gets feedback right away if something's wrong. If there's a change that breaks, you've got a smoke test cycle, you've got a QA testing cycle. You can catch problems before they reach production. So you don't have to disrupt production. You don't have to ship code that customers will have trouble with. And you can do it fast because it's all automated, right? Ideally, this check-in, build, smoke test cycle should take maybe 10 or 15 minutes. You want it to be fast because you want your developer to get immediate feedback about what's going on. And this pipeline allows you a new concept. And this comes out of containers. This is one of the reasons why Docker is so important, why DevOps is so important, and that's the notion of shifting left. If I'm in production, if I'm running a service and I need to make a change, I don't make a change in production. I shift it left. And I go back to developers and say, hey, I need this change made in production. Please make the change for me. The developers make the change, they check it into version control, it runs through the pipeline, and the only thing I ever deploy into the live environment, the only thing I ever deploy into production is code that's been built and tested and confirmed to be good. So I don't get the crises in production. I don't get the pager calls at 2 o'clock in the morning. And if there is a problem, here's where DevOps comes into the fore and comes to your aid. If my software is containerized and the new one goes wrong, well, I shut down that new container, I spin up the new container, the old container, and I'm back where I was before. No harm, no foul. We push it back to the developers and they fix the problem. It's really cool. That's what we mean by CI and CD. Okay, this is oftentimes seen kind of as a line. I've broken it in half just to fit it on the slide. But generally, I see the top half here, the version control and the build and the testing to be continuous integration, because after the smoke test, we have a new version of software and all the changes have been integrated and confirmed. The bottom line here is what I call continuous deployment or continuous delivery, because we can automatically do QA testing, we can do any packaging or deployment that needs to be done, and we get it into production, and there we go. So it's really cool. This is what you'll see in industry. This is what you'll see, I think, at the best run companies. Now, the tools may be different, but the concept's going to be the same. So finally, there's the question, how do I get started? What do I do here? Okay, well, I think a good education helps. And if you've come through a university, you probably have that. When you get to the notion of, I'm going to learn about version control and I'm going to learn about test-driven development, we're not really talking about data structures. We're not talking about machine organization and these traditional computer science topics. This is a little different level. It's a little different view. So understanding that fundamental computer science helps, right? You need to know the fundamentals, but you need to know a little bit more and a little different knowledge than maybe you'd get in university. It helps to do some work, right? This is an important domain. This is an important role to fill, but it's not really possible to go get a degree in release engineering. But what you can do is some personal projects. Now, if you're learning through Skill-Lync, you're going to see challenges and you're going to see projects, and those are good because you can save your work and you can build a portfolio of the work that you did. So when you go on an interview, you can talk to your employer. Hey, this is what I did. This is what I learned. This is what went well, what didn't go well. Now you might say, well, okay, but I don't have that much, and I'm still learning how to be a developer, and I don't have a lot of development experience. Well, you can contribute to open source projects, and that's really an important way to get some exposure and to see how really serious software projects run. Now, if you're not ready to contribute code, right? Certainly, you're probably, only a few people are going to be contributing, say, to the Linux kernel, but you can still test, you can write bug reports, you can fix documentation, but by contributing to the project, you can see how it runs, you can see how it builds. I think when you look on open source projects, you'll see a lot of these ideas in use. Again, the tools may be different, the concepts are going to be there. Obviously, you want to learn the popular tools. If I'm going for a development job and I don't know Git today, then I'm at a real serious disadvantage, and you really want to know the current tools. But it's also important to learn and understand the fundamental concepts that are behind these things like configuration management, version control, and build. Because the tools you learn today, the tools you use today, aren't going to be the ones that you use forever. Right? We talk about today Git being a really important version control tool, and it is. But before it, Subversion was very important. And before it, CVS was important. And before CVS was RCS and SCCS. Now, you may not see these old version control systems around anymore. But my point is that things change. They always change. If all you know is Git, then the next time there's a change, then you're going to be at a disadvantage. So yes, learn the modern tools, but also learn the concepts and keep them in mind because they're going to help you moving forward.